on. It seems to be happening. I just got a message myself. So also to ask questions along the way, we ask that you use the chat function in your Zoom browser. So you can just anytime you can ask a question, but it's specifically there'll be two sections, and the first section will end, and then we'll try to answer questions from that, and then the second session will go forward, and then after that we'll have more questions, and both of our speakers will be able to answer at the end. Thank you for joining tonight's seminar discussion of trees, forest, ecosystems, and climate change. And for those of you who survived the weekend, I'm sure you probably want to know more about what's going to happen with climate change. We have two exceptional speakers on this topic, and it's really my great pleasure to introduce them. Both of our speakers, Dr. Richard Hebda and Dr. Andy Mckinnon, have long and incredibly distinguished careers as scientists working with the BC government. But each of them has also had and continues to have an extraordinary impact on society as teachers of key understandings about nature and how we can live with and enjoy it. In short, Andy Mckinnon and Richard Hebda are awesome naturalists. Dr. Richard Hebda retired from the Royal BC Museum as curator of botany and human history after more than 30 years of scientific and anthropological research there. In his spare time, he's been an adjunct professor at the University of Victoria, taught numerous university courses, and I can vouch for at least one of them, having taken a paleobiology and evolution course from him way back, and it was an awesome course. And because I'm not getting a grade, I can say that without reservation. He taught extension courses for the university, worked with the Pacific Institute for Climate Solutions, in where they modeled both past and future climate scenarios. He's authored more than 130 scientific papers, hundreds of popular articles about nature and climate and gardening. His books include a guidebook to edible plants, studies of ethnobotany, and a fascinating archaeological study, Teachings from a Long Ago Person. He's an accomplished gardener, and he's in demand by the public for public speaking on this topic, and he grows, and I can vouch for this as well, he grows incredible irises, among other things. Dr. Andy Mckinnon, our second speaker, worked for over 30 years as research for the research branches of the BC Forest Ministries. Among other things, he was responsible for ecosystem classification and mapping and a program of forest ecology research focused on old growth, structure and composition, effects of climate change, and BC's native plants and fungi. He's responsible for key reports on ecosystem-based forest management for Haida Gwaii and other places. And we all can wish that politicians would have paid more attention and should pay more attention to what Andy's work has been. He's also, like Richard, gone way beyond his ministry careers to teach and communicate about nature and science. He's an adjunct professor at Simon Fraser, teaches several forest ecology courses, including one at the Banfield Marine Science Center, where I was meeting him and met all of his students who loved the course. He's also a prolific author and has co-authored, I'm not sure, 8 or 9 guidebooks about nature, especially plants, including Plants of Coastal British Columbia. Everybody should use that. And he's just coming out with Mushrooms of British Columbia in the BC Museum series. And Erin Ann, you have, at least in my, you're highlighting Susan in my window, but I was hoping you'd highlight at this time Andy, who could show people in the audience his book, Mushrooms of British Columbia, which will be coming out soon. Everyone should have these books, guidebooks that he's done, hint, hint. So Andy is also, and it's amazing how much he is able to accomplish, a counselor in the municipality of Metchosin, and he developed a motion to ask the BC government, to stop old growth forest logging, which was ratified by the Council of BC municipality. So we should all be, and especially the governments, should be listening to scientists. And tonight we get the two best scientists in British Columbia telling us about trees and forests of our island and of BC. So again, if you have questions, please uh, write them into the chat. We will have about 25 minutes with Richard speaking first, Dr. Richard Hebda, and then we'll have questions for about 10-15 minutes, and then Andy will take over and we'll be able to ask him questions along the way as well. So at this point, I'd like to welcome Dr. Richard Hebda.
Well, hello, and it's a great pleasure to talk and meet again, whether electronically or otherwise, the people of Salt Spring. There's a few people I noticed on the list that I know, and I'm glad to be able to speak to you on this very important topic. One of the things we should add to the land acknowledgement is that the land is also part of the territory of the Douglas fir and the Garry oak and many, many other species who have just as inherent a right to live on this land as the rest of us. And this is a deep moral issue, moral commitment we should all have to share. And we aren't, and we need to, and in whatever way we can, we must be out there to fight for the forests. And some of what I'm going to say today will be related to that. I'm going to introduce quite a few ideas about climate change, how rapidly it's happening, much faster than originally I had imagined. And some people say 25 years ago, 30 years ago, you told us so. And I said, yes, but that was for the year 2080, not for the year 2021. And then I'm going to suggest a few things that you can do and some strategies, particularly focusing on carbon stewardship on Salt Spring Island and everywhere else. So let me see if I can share my screen here without too much trouble. And here we go. And here we go. Excellent. So everybody see what I got there? So Salt Spring Island, what's happening to our forests and trees? And I may be fairly quick. So first message, climate change is underway. I think we'd all now agree from the past week, prepare and adapt for change. I heard some wise person on the radio said, well, this was a once in a lifetime event, this heat wave. They're wrong. It's going to happen in maybe the once in a lifetime event of a 70-year-old person like me, but I don't think so for my children and younger people. There's a misunderstanding right there. Global temperatures are now up 1.2 degrees Celsius. We're all talking about let's stop at 1.5. It's not going to happen, and we'll be lucky if we stop it at 2. Just the numbers for you to think about. Victoria record temperature on the 28th. Yesterday's data, that was this is from the website, Environment Canada, 39.4, minimum 20.7. Normal conditions are 20.6 and 10.2. This is not just a gradual increase or a change. This is a transformation. This is a transformation, and it's the beginning of more transformations to come. I show this little graphic here that talks about extremes, and this only takes us to the year 2013. If you take a look at the top, land summer temperatures in the Northern Hemisphere, how often do we get extremes? If you look for the 1950 to 1980 record on the left, never, 0.1% of the time. If you look at 2011 to 2013, those extremes that occurred 0.1% of the time were occurring 14.1% of the time. And I would bet that if we had this recalculated, and I've looked for it, but I haven't, that extremes now are much more than that. We no longer live in the world of the 1950s. We now live in some world that we have a glimpse of from the past, but we've never experienced. 2020, warmest year ever recorded, tied with 2016. This year may not be quite as warm because it was a La Nina year. Nevertheless, it's still one of the warmest years, or will be one of the warmest years we've ever experienced since we've made measurements. And just take a look at the Northern Hemisphere and the Arctic regions, where some areas such as Siberia, places I've been in Eastern Siberia, where the temperatures now have changed as much as 5 to 7 degrees Celsius annual temperature. Carbon dioxide is rising and there's no end in sight despite our attempts to do something about it. The levels exceeded 420 parts per million in May for the first time in at least 800,000 years, if not more. They began at 280 parts per million. The point is, parts per million doesn't really mean anything because this is such an effective gas in holding heat in the atmosphere and hence warming the earth. And that was the level in pre-industrial times. So we've already increased a huge percentage of it. And most of that percentage, 35% of that original level, the increase in it has taken place in only the last 15 years. And we know that because I have an exhibit that's in the museum. And that's when that climate change exhibit went in. And it was a bit of a challenge to get it in because people said, well, you know, climate change, it's a hoax, doesn't exist. Fortunately, the person who is heading one of the great powers of the earth has gone now, and we can ignore that call to falsehood. US drought 2021. All that black stuff on the left-hand side, this is exceptional drought. And if you take a look over on the right-hand side, it tells you what some of the letters mean. And S and L letters mean short and long-term drought. And these are droughts that have long-term impacts, not just on crops and things, but on hydrology and ecosystems. And this is where the action begins to take place. When you have droughts of this nature happening in huge parts of the continent, you are transforming hydrological systems and transforming ecosystems and ecology. And that process is now underway. So we are leaving the earth that most of us grew up in and moving into some condition that we can get insight into. And I'll talk a little bit about that. But very soon, within a decade, 2 decades, we are going to be in a world that's quite different from the one that people like I, who are 71 years old, grew up in. And you don't have to go to the Western United States. 2 years ago, we had to pump water from the Cowichan River to keep the from Cowichan Lake to keep the Cowichan River going. And this is these sorts of extraordinary measures are now occurring all over the place. We'll remember, I certainly will, I was doing some work in the interior, the 2017 and 2018 forest fire seasons in which over 1 million hectares of forest burned because the forests are drier, the summers are warmer, and the burn season is longer. Hold on to your hats for this year. Let's hope there aren't too many lightning strikes. There are many idiots out there with ignition sources. This may not be a good year for keeping the forests green. And last year, just to keep the forest fire story going, 2020 in Oregon burned. And people were just astounded because nothing like this had ever happened in Oregon. So it's not happening just in British Columbia, Washington State, Alberta, and up into Alaska. And now last year we had forest fires, if you could call what grows up in northern Siberia forests. The trees are 5 feet high and 400 years old. And they had the tundra and the taiga burning where it never had burned before. One of the other impacts, and I'll let Andy talk more about this, is that it, of course, is affecting the ecology of our province. And here's an image of the Sunshine Coast, very wet place, but the soils are shallow, poorly developed, growing on granitic bedrock. And not only cedar trees, which we're all familiar with, dying, but the lodgepole pines, which are very drought adapted, are drying. The point is, if there's no water, no matter who you are, as a tree, you die. You have to have water. And now there are other species suffering. Just a little bit about the craziness of our weather. in the last week. One of the, and I won't get into this because otherwise there's so much to be said about this, but one of the phenomena is changing in the position of the jet stream or its disorganization. It really doesn't know where it should be. In normal, stable conditions, the jet stream kind of goes up and down around the north and south poles. And here we see it's attempting to go up, and then it kind of fragments and then starts all over again and fragments again. And this is a consequence of the fact that the north is not as cold as it used to be, and the south is warmer, and the gradient between the two is less. And the strength of the jet stream, the boundary between warm and cold air, is less defined. And this probably suggests a chaos in the atmosphere and in the weather pattern, and basically into movement into some kind of climatic regime shift. Now, I'll talk about that for a bit. Future temperatures in the USA, let's take a quick future global temperatures, take a look at what the US EPA says. If we keep up to what we're doing now, we're going to increase by 4 degrees Celsius. That would be like more 10 in the north. If we do a little bit, we might keep it at 2. As I said already, we're at 1.2, which is above this line. So forget this, whatever this scenario is, it's not very likely we're going to meet this scenario. We're probably heading for this one here. We're actually at the moment, from what I can tell, on this track in terms of emissions and the response of the atmosphere. Future temperatures globally depends on what we do. We don't want to go down into here, which is the Earth, and this is achievable with bad carbon dioxide and other greenhouse gas management. 11 degrees Celsius globe will be something that's just impossible to imagine by the year 2200. We're hopefully staying down somewhere in here. But you can see no matter what we do, the temperatures are going to increase. And if we don't take real action soon, we're going to end up somewhere in this red zone, which is just be utterly transformative, to use a descriptive term. And one of the concerns is that the temperature and carbon dioxide concentrations in the atmosphere are very tightly linked. And we know this from looking at carbon dioxide in ice sheet bubbles, air bubbles. And as one goes up, the other one goes up in quite close relationship until now. Such a rapid and sudden increase, greater than the ones we've experienced in other transitions, has just occurred in terms of CO2 concentrations, that the temperature, which normally would track with the same sort of spacing here, has been unable to catch up. In other words, we're pulling on an elastic band, and at some point that elastic band is going to release and the temperatures are going to pop up. And we haven't got to that point yet. If we take a look at what this means in terms of ecology on the continental scale, if we look at the left today, which is today, isn't really today. Today is like 20 years ago, which changes have already taking place. Just look at the greenish yellow in here. This is the plains prairie ecosystems. Take a look at where that climate, and hence given equilibrium, that vegetation would occur, moves from the middle of Alberta, touching into the Northwest Territories. And there are all kinds of remarkable transformations that occur in the West at very fine scales. So it's very important to be concerned at the local scale, at the Salt Spring Island scale, to the transformation of ecosystems, because that's the scale at which those changes are going to take place in our region. And just a quick look to the east, you've got an eastern deciduous forest now, the Carolinian zone and its sort of northern transition zone occurring around James Bay. If we take a look at some of the models that we developed, looking at what our ecosystems might do, understanding that because these will change species by species, it won't be biogeoclimatic zone by zone. It'll be whatever the species do, whatever happens to them as they change their locations. So it won't be what we understand today. It'll be some kind of different ecosystems, but red grassland climate by 2080. grassland climate by 2080. Orange, you can't even see it here. That's ponderosa pine ecosystem climate. Orange, ponderosa pine ecosystem climate in 2080, reaching up into the Northwest Territories. Ecological transformation on a scale probably not experienced for a very, very, very long time. If we take a look into the past, and this is important because if you look in the past, you can ask the question, well, was there a time that was warmer and drier in the summers? And the answer is yes. And what did that British Columbia look like at that time? And we know this from the study of lake cores, or in this case, for our close to Salt Spring, from the study of Saanich Inlet a few years ago. If you take a look, in this case, I kind of reversed it. On the right-hand side, yellow is grasslands. On the left-hand side is 9,000 years ago, when it was slightly warmer and drier, about a degree or two, the extent of grasslands. Very similar to what the models tell us. If we just take a look over in southeast Vancouver Island, it's all brown in here. That's the coastal Douglas fir zone climate. If you take a look over here, I'll make a close-up, not the clearest, but here we go. Here's your coastal Douglas fir climate, which begins to extend throughout British Columbia, Vancouver Island, and on the coast. But our east coast of the island, southeast area here, converts to open vegetation. In this case, it would be Garry Oak Meadow plant communities. I just should point out there are a couple of high spots on Salt Spring that remain brown. So yes, there is a future for trees on Salt Spring and the CDF. A study we did on tree rings in the past, going back over 4,000 years, they were preserved in the lake, Heel Lake, where the dump is now for Victoria. And when we looked at the last climatic transformation in our region, which was a cooling and a moistening, it happened around 4,000 or so years ago. It's well known for this transformation throughout the Northern Hemisphere. The trees did not sort of gradually grow in a different way. This is a section of Douglas fir that grew at that time. It lived to be maybe 250, 300 years. The transformation takes place right here. And that change of growth takes place in about 10 years, and most of it in 3 years. In other words, when we have climatic regime shifts, they don't go from one situation to another. They often flip, they undergo state shifts. So it could be any year now. Given the nature of the climate we've just experienced, it could even be this year, given the intensity of this and what might happen in the next couple of months. But certainly it will not be gradual. We'll wake up one year and say, huh, I'm in California, baby. And that isn't really good for us because our ecology is not California's ecology. So future conditions, some of the challenges we face: warming from 2 to 5 degrees global and 5 to 10 degrees in the north. Intensified droughts and rain. So paradoxically, more extremes, heavy winter rains, intense summer droughts. Extremes and local, on the local scale, regional effects affecting small populations and fires. The climate change is more rapid than evolution and migration can deal with. Species can't migrate this fast. They certainly can't evolve this quickly to the new climate. And therefore, we're going to see ecological transformation of an incredible scale. And I add to this, and this is something we can do something about, and you can do something about on Salt Spring, is reduce the intensified human pressure, mainly land conversion. Too many people wanting too much from the land, not respecting the inherent right of the organisms that live on that land. Impacts are faster and more intense. Generally speaking, ecosystems and processes more sensitive than the model predictions. Everybody's saying, well, we're surprised at how quick everything is changing. I'm not surprised. I'm a little bit surprised. But even the meteorologists are saying, wow, we couldn't foreseen this. Well, that's because you don't understand natural systems. Expect transformative events. In other words, you'll have an intense drought and it's going to change everything. Maybe a disease will move through. A pest outbreak will happen and it'll have tremendous impact on a particular species. The variation, yes, on a large scale, like this extreme heat event, but it was likely vary from place to place on a small scale. The south side of a hill will be more quickly and intensely affected than the north side of the hill. Increasing disturbances of all kinds. So we're not at a time of equilibrium, we're at a time of disequilibrium and disturbance. In the species responses will be difficult to predict because it'll be on a species by species basis, and it depends on what the stressor will be and what's hidden away in the genome and the genetics of the individual species and populations. And we'll certainly see new ecosystems because the species can't migrate that quickly. And some will be more adversely affected than others. And as I said, there's the whole issue of temperature lagging the CO2 concentrations. So we're in for enormous changes, adaptations and strategies. What can we do? I'm not going to talk about all of these. I'm going to focus on a little bit on ecosystem conservation, restoration, but particularly on carbon stewardship. But other important things to be concerned about and think about are assisted migration. When I normally give this presentation, I talk about these issues. I talk about managing water and a very important one, food security. And some of you may have know about our project called heritagepotato.ca. That's one word, heritage potato, as we begin to experiment with unusual heritage varieties all across Canada to see what will grow where and why the heck people import potatoes in northern British Columbia from Idaho when they can grow perfectly good potatoes there themselves. Carbon stewardship. I kind of think of carbon as existing in three forms. The living carbon, that's the plants, animals, organisms, everything in there. Trees take CO2 out of the atmosphere. They affect ecological processes. The living biodiversity is the future insurance of a world, of some natural world covered in something or other. The dead carbon is the organic matter in the soils, both on the surface and within the soil structure itself. And of course, it sustains the living carbon and it sustains mushrooms and fungi, as we're learning. And then there's the ancient carbon, fossil fuels. But I'm really going to talk about trees now. Every tree matters. Every tree out there is doing its job through photosynthesis, taking carbon out of the atmosphere and turning it into living matter, which eventually then gets turned into dead matter, or a lot of it. The problem is that we're not only converting ecosystems, but Amazon, destroying them, but we're degrading them at an incredible and an intense rate. And this is a very serious issue because it's the second major cause of climate change, because it emits CO2. 20% more or less of the CO2 that's going into the atmosphere is a consequence of degradation and conservation of natural systems, mainly forests. Furthermore, by destroying natural systems, forests, you reduce the bank account of life, the bank account of options, and reduce the options in the future as the climate changes. So what do we have to do? The bottom line is we have to cover everything in living creatures, trees, and restore all the carbon sinks. Get photosynthesis to its max. Because, as I said before, plants remove atmospheric CO2 for free. For free. Well, we have values for the land. We want to use it for something, but we don't. Those plants are going to do it if we leave them there. So, message, do not remove the trees except for ecological purposes where you might have some competition between non-native and native species, and the invading non-native species are causing degradation of the natural ecosystem. Conservation, fantastic. Salt Spring Island Conservancy and Land Trust, the conservation efforts are fabulous. Here's an example in Machosen. I don't know how to pronounce it. Andy will probably correct me and give me a proper pronunciation. Every stand of old trees must be conserved. And it doesn't mean preserved, so nobody can go in there and do anything, but conserved. So whatever human values or interests or uses of that, then is sustainable to the ecosystems that are there, particularly the living organisms and large trees. And here's a graphic that we used, Sarah Wilson and I, a few years ago for the Land Trust Alliance of BC, and one that should appear and people should have hammered into their heads, and land managers need to have it tattooed on the inside of their eyelids, and especially politicians need to have it inside. You keep an old forest alive, it just keeps on going like the Energizer bunny storing carbon. People say, well, no, chop it down, we can plant new ones, we'll save carbon. But no, you won't, not for many years. And by that time, the conditions will be so different that you don't even know whether this is going to happen or not. So chop it and replant it, you're going to emit carbon, and then maybe you'll get on a positive balance. And if you convert these sites to housing or whatever other human use that is not consistent with the need to keep nature on the landscape, you end up blowing the carbon out first by chopping the trees down. Sure, you might get a few sticks out of it that they don't live that long in buildings, despite what everybody says, but you have organic matter that decomposes, and because you increase the soil temperature, the organic matter stored in the soil, and our soils, Salt Spring and West Coast soils, store huge amounts, some of the greatest amounts of organic matter stored per hectare in the world. We are committing the greatest sin in terms of releasing carbon by destroying our forests. Forget the Amazon. We're way worse off in what our impacts are. So optimal carbon storage in natural ecosystems, old forest. Here's for our dry climate, 250-year-old Douglas fir forest stand. And you can't have a 250-year-old or 150-year-old stand if you cut down your 100-year-old forest. You don't cut it down and say, well, maybe 100 years from now, if I replant now, I'll have this on Salt Spring. In many of the sites, we know from the work in Saanich Inlet that if you cut down the forest now, you will never, ever have a forest there, tree or trees there. The ones that live there have their root system in there. They're well established. They figure it out. Some of them may die, but you are not going to be able to replant and restore that forest. So thinking about the future, prepare for extremes and surprises. Some places there'll be floods, droughts, pest outbreaks, and impacts from outside of BC, like the increasing price of timber. So let's cut it all so we can make more money the quicker we can. Foster bold experiments through forestry plantings, through assisted migration, which I'm not going to talk about, don't have the time, for policies and incentives that maintain forestry cover, forest cover, conserve the value of the natural ecosystems that we have, and maintain this insurance of life that blankets our landscape. If we don't do anything, then we have the extreme risk of negative impacts. We now know absolutely smack dab right into our heads, extremes will occur. The ecological consequences of these temperatures that we've had, we don't know, but there will be very serious ones. And if it doesn't rain until September, we're going to see huge amount of tree dying on dry sites, Douglas firs, for example. I'm now going to pass over the conversation to Andy Mckinnon, who can talk about individual tree species on Salt Spring and in general, but I'll be happy to answer questions.
Well, sobering, Richard. That's about all I can say at this point. There have been a couple of questions, quite a few points that grasslands are also carbon sinks. And of course, that brought a question from my mind. You mentioned and you showed the graphs that the Gary Oak grasslands were around in the past in a warmer time, and it looks as though much of our island will be the ideal ecosystem as Gary Oak grasslands in the future. Do you have a comment on how, if we do have die-offs, how we would make a transition into Gary Oak grasslands? Do we plant Gary Oak grasslands kind of species in reforestation in those sites? What will happen?
Okay, so yes, the climate for that kind of ecosystem will expand, and you have to anticipate that. And what I would be doing right now is I would be planting in suitable sites. And again, you need to have good land mapping conditions and get a really good map of the drier sites, the coarser textured sites, and you begin, if you don't have them already there, planting Gary oaks. And where they are Gary oaks, you make sure they're there. And one strategy or one example I use is I have a slide of the distribution of sea blush, plectritis. And I said, well, here is your excellent indicator of where you could be planting Gary oak trees, because sea blush grows in sort of in full openings, but often shaded openings, but on shallow soils in our coastal forests, and actually in many of the forests outside of coastal Douglas fir. I can guarantee you that those sites will have the trees around them, rocky knolls, shallower soils, die out, and they are perfect sites for in-planting Gary oaks. Forget the conifers. They're not going to be able to get enough water in the shallow soils. So plant Gary oaks as a starter. And if they're there, and you do it now, because you know they don't go fast. I mean, they can if you water them and give them a good start at the beginning, and they'll be there because they can tolerate pretty dry conditions. They grow Gary oaks specifically right down into coastal California, and that's the kind of climate that we anticipate. And along with the oaks, of course, if the species, the shrubby and herbaceous species aren't there, then facilitate them spreading there or plant them there as well. So yes, put the oaks in there. There's nothing lost in planting them there. And I guarantee you that in a few years' time, they'll thrive. I'm doing it on my own property. I'm in-planting. What I do is I in-plant my stand of trees of my bitter cherries, which are reaching the natural end of their lives, 50, 60 years old. And we are now in-planting Gary oaks to replace them.
I have friends on the south end who I think will really appreciate that advice, because they're seeing some of the arbutus and Douglas firs die on their property. So related to this, I think is a question from Francis Pugh, who points out that when you were here the last time, I believe that was 2003, you really inspired people by explaining about your lake studies and your studies, core sample studies on Saanich Peninsula. And this Francis is asking, are there lessons from that information that could help us envision adaptations here on Salt Spring?
Absolutely. One, you can map or get a really good sense of where the dry sites. Let's put it this way. We know from the work in Saanich Inlet, and actually somebody's done a core from Stowell Lake, but I don't see that the results on the pollen has been published, but I think I've seen them. So there's a study that's worthwhile getting hold of. It's through UVic biology department, but Saanich Inlet absolutely reveals that there will be extensive open tracts. The coastal Douglas fir zone will forest cover will be much reduced, and there will be in time, when some kind of level of stability is reached, and provided we don't mess things up too much, will be way more Gary oaks, and on all kinds of sites, including dry sites. But even on the suggestion from that study was that we even had them growing on the floodplain of the Cowichan River and the Coxsila River up the valley of the Cowichan River right up to Cowichan Lake. So that's the first lesson, that this is not hypothetical. This is exactly what happened the last time. So that's the lesson. And there are other things. Western hemlock, you can forget about it. Most of them will just die. Western red cedar, it had, this is the kind of stuff Andy can talk about, but it just wasn't there. So there are very clear messages and lessons from that, which is basically a topic study of another presentation.
Fantastic. Garden Dodd asks the question, what is your view on fire suppression?
Okay, so my approach to that issue is we don't want fires on Salt Spring Island. Or in areas like ours, and the situation in Kelowna is the best example. The rural areas just burned with terrible consequences because there are trees all over the place. So what we want to do is you need to suppress fire, but what I'm getting at is you cannot use fire on a large scale on Salt Spring to transform the ecosystem to be fire tolerant. But what you can do is do all the basic fire smart things in areas around people's houses. Keep the shrubs down, remove the fuels. If you have fuels, and I do this around my house because I live right next to a 120-year-old, basically at the edge of a forest of that age, and take all the organic matter you can, chip it up or break it up and lay it down on the ground in the forest to act as a mulch, as a food, as a substrate for the magnificent fungi. Many species are still being discovered. Andy will know the story, and it just blows me away that Adolf and Aluna Cheshka have looked at just the Dominion Astrophysical Observatory hill, this tiny little hill of a few hectares, and have discovered over 1,000 macrofungi species, 1,000 on that little piece. A whole bunch of them never known to science before, and they keep finding new ones. Can you imagine how disrespectful we've been for the fungi and the whole story of the role of mycorrhizae? So take your organic matter, all your shrubs, don't take them away to some chippy choppy place somewhere else. Put them back in the forest, crush them against the ground or squash them against the ground so they're not ladder fuels to start fires, and let them feed the forest and the fungi.
Excellent. I think maybe Andy will have to revise his book again with some of that information, but his new book, Mushrooms of BC. But a couple of people have mentioned that we have deer on Salt Spring. We have, and some of the studies have shown that we have way more deer than this can sustain, but that that young oak trees are susceptible to deer browsing. So do you have any suggestions for the growing oak problem?
Cage them. That's what I do. You just get big cages, put them up until they get so high that they can't get in them. The other thing that I would use for anything that you want to preserve, and the garden audience may have heard me say this, is you get meat meal from Borden's and you sprinkle it on the leaves and they won't touch it. You have to replace it every once in a while. You don't need very much, just dust them a bit and they basically won't touch them unless the population is incredibly high, which in our rural natural areas is not so bad, maybe in Oak Bay. And as we have had just this year, we've had an utter crash in the deer population because there was a huge overpopulation last year. We could see them getting sick and getting diseases. They died around our home, and now there are fewer of them. So, but yes, cage them. If you're going to put the investment into planting an oak tree, put a cage around it, water it in for the first 2 or 3 years so that it gets well established. Bring in oak leaves if you have some to mulch around the base of the tree. Oaks love oak leaves around them.
Okay, I'm just going to do a final question here and then turn it over to Andy. So the question is sort of on the political side of things, and I'm going to kind of combine a couple of the points that were made in the chat here. On Salt Spring, we have a different form of governance than the municipalities in terms of cutting trees and private property management of trees and forests. I would say mismanagement is probably a better term overall, especially in the light of what you've just said about what we should be doing for the future of the island. So do you have any comments on suggestions for the politics of managing to keep our forests and our private land forests intact here, because that's going to be a huge issue in the future, as you've said.
Okay. The first of all, what I say is the rights of other living creatures trump stupid people's rights to property and to make a profit off of nature. And that is a moral issue we absolutely have to face and confront now. It is an ecological sin from my perspective for this to happen. And I think we need to couch this all in this thing, not the impact of this on people, but the impact of this on the other creatures we share this planet with. So it's a moral issue. Now, you don't hammer that down people's throats. You begin to discuss this in that kind of context. Next thing I would say is, these are rules made by people for people. Those rules can be changed. The form of government can be changed. People can just say, no, we don't think these rules are working, and they're clearly not working. And so you take action. And the best example is the Fairy Creek blockade. Whatever piece of stupid paper you wrote something down, and of course we need law and other kinds of things like that, but there are certain things that in which they don't apply, and they do not apply in this situation where we're transforming the globe. The other thing is that you can take your own community action, and the land trusts and community groups that are using their resources to create covenants, for example. Talk to the people to see if you can get them to put covenants on their land so the next landowner can't do it. Talk to your neighbors, even if they have a particular view of the world, and express to them how serious an issue this is and how important it is, that this really is a question of capital M morality. This is not a question of money. Be persuasive, talk to them, and take the opportunities, the easy ones first. Gather up your money, buy the land. If money is all that somebody understands, and find the money and buy them out. And then you are taking the right action.
If I might follow up on Richard's response there, just with a point of view from a municipal politician, as a councillor in Metchosin, I wrote the tree management bylaw for our community. And municipalities in British Columbia, as Dave mentioned, have opportunities to do things that are not available to the trustees in the Island Trust right at the moment. So I think it's also critical that the trustees in the Islands Trust ought to be petitioning the Ministry of Municipal Affairs to give Islands Trust access to better forest and tree protection policy tools than they have today, at least the equivalent of what's available to municipalities.
Great, and I might also mention that the Salt Spring Conservancy is doing some of the things. We need to really scale that up on a big scale. So go out to the Conservancy and get those actions happening. And with that, and I seeing that Andy is front and center on my screen, at least, I'd like to introduce our next speaker, Dr. Andy Mckinnon, to speak on trees primarily, but more. Here you go.
Thanks so much, Dave. I'll begin by sharing my screen here. Can you see that?
All good.
Let's go. There we go. As a proper slideshow. So first of all, thank you, Patty, for the wonderful land acknowledgement. I thought that was very heartfelt, and I appreciate you putting that into words for us. As Richard has explained, our climate is changing, and my role tonight is to explain to a certain very limited fashion how changing climates are affecting forests and trees on Salt Spring Island. Now, it's good to see a lot of names that I recognize at the presentation tonight. Hello to all. Salt Spring is graced by the presence of many great biologists and ecologists who know an awful lot about the island's forests. And I think that Richard and I have been brought in tonight as experts. An expert is somebody who is more than 50 miles from home, has no responsibility for implementing the advice he gives, and shows slides. So I brought some slides for you tonight. I'm going to be talking about what we've observed, what we should be keeping our eyes open for, and maybe talk about some solutions at the end. I hope that can continue as a discussion. I just wanted to mention that an awful lot of what Richard and I tell you tonight will be wrong. Anybody who pretends that they can predict the ecological consequences of a changing climate in any detail should not be believed. And if you take one message from my presentation, my main prediction about the response of species and ecosystems to a changing climate is that we will be surprised. One of the best examples of that is a species that we're not familiar with on Salt Spring Island or in this part of the world, really, yellow cedar. And this is from some good friends in Southeast Alaska who started noticing the decline of yellow cedar in Southeast Alaska. We subsequently mapped it together down through the Central Coast to the Quay drainage, at least a number of places on Haida Gwaii. The yellow cedar was dying. It turns out, after some very clever work by Paul Henham, Dave Damore, and others, that what was going on is that increasing seasonal temperatures were reducing snowpack in certain soil types at critical times of the year. And so removing that blanket from the shallow-rooted yellow cedar trees, and their roots were freezing. So yellow cedar decline throughout most of its range, at least where it's been demonstrated, seems to be the results of the tree roots freezing because of increasing temperature. And if you can think of a better example of an unexpected outcome than that, I'd love to hear it. I'm sure there will be many, many more. The bottom line being that we'll make some bold predictions here, a lot of them based on stuff we've already seen. But if you're trying to predict what is going to happen to species and ecosystems in the future, we can take our best guesses, and they are that, guesses. One thing, we have one model to look to, and Richard was talking about looking at paleoecological evidence, which is wonderful and is useful in trying to make predictions about the future, but I think we're going to be confronted with a lot of surprises. It's important. I was talking with someone the other day, and they were talking about the future effects of climate change, and it's great to see presentations like Richard's, where he explains quite clearly that climate change has been going on for a century. We're 1 degree warmer mean annual temperature than we were 100 years ago. So climate change isn't something that's going to happen. It's something that's been happening, and we've been seeing its effects. He was talking about the ecological zones in British Columbia, gave a few good examples. One of the ones that's of great interest to me is that as climate warms, the tree line, the upper elevation at which trees grow, increases. So climates which were inhospitable to trees because of their elevation before are becoming more hospitable. And as that happens, the alpine, the area above tree line, disappears, as do all of the alpine species that are so near and dear to a lot of us. A lot of models predict that the alpine will be gone or nearly all gone in the southern half of our province in 50 years. Bit of a sobering thought. He also talked about Western hemlock, for example, which is a tree species which is very uncommon in the coastal Douglas fir zone, in which southeastern Vancouver Island, the southern Gulf Islands, including Salt Spring, except its highest elevations in the coastal Douglas fir zone. If that climate spreads to a larger area of Vancouver Island, then the areas in the driest sorts of coastal Western hemlock forests right now that support Western hemlock might be expected, certainly within the next 50 years, not to support Western hemlock anymore. And that's one of the interesting things that foresters, forest managers are facing today. I think forest managers are some of the people who have to make the earliest decisions about changing climate. Are the trees they plant today going to be able to survive in the climates 50 years from now or 100 years from now when they want to grow them to? If you're working in agriculture, if you're working in municipal systems, you can probably wait and see a little while. But decisions that we make today about tree species, some of the things Richard was talking about, have to be able to withstand what we expect to happen over the next number of decades. I'm going to talk primarily about tree species, but we're also going to see some important changes in disturbance regimes. Richard touched on this. Wildfire, the worst ever wildfire year on record was 2018 with 1.3 million hectares burned, but that surpassed the second worst, which was in 2017 with 1.2 million hectares burned. And as Richard pointed out, right now we're in the midst of an historic drought with record high temperatures. Stay tuned and hang on. But it's not just the wildfire as a natural disturbance process that we expect is going to be profoundly changed by a changing climate. People are keeping a really close eye on what a changing climate is going to mean for insects and fungi that attack and sometimes kill tree species. The best known example of this from British Columbia is from interior British Columbia primarily. This is the mountain pine beetle. You can see the map on the lower right-hand side showing the observed presence of mountain pine beetle from 1999 to 2012. That's actually not a bad map of the distribution of lodgepole pine in British Columbia. So everywhere pine was, we saw mountain pine beetle, a consequence of forest management practices like planting too much pine back on the landscape. Fire suppression was almost certainly important, but we've had lots of mountain pine beetle epidemics in the past. They always end when there is a winter temperature which is cold enough to kill off the overwintering beetle larvae. And throughout the 1990s and the 2000s, we just didn't have those kinds of cold temperatures in interior and northern British Columbia. And as a consequence, we had more than 10 million hectares of lodgepole pine killed by mountain pine beetle in those 2 decades. In addition to seeing increased activity from some of the fungi and insects that currently attack trees in British Columbia, the people who do the forest insect and disease surveys are keeping a really close eye out for some of these creatures which we know from Washington and Oregon, but not yet from British Columbia. We expect to see new insects, new fungi arriving in British Columbia and probably beginning to affect our forest here in the province as our climate continues to warm. Now, this is supposed to be a terrestrial talk, but I just wanted to point out that, and I saw something about this in the chat as well, that there's a lot of carbon sequestration that goes on in non-forested landscapes, including in marine landscapes. And there are groups on Salt Spring and a lot of areas around the Salish Sea that are beginning to focus on all of the sources of carbon sequestration, not just in forested habitats. And some of the numbers that are coming out of the amounts of carbon that are being sequestered in eelgrass meadows and similar ecosystems are quite extraordinary. So that's a pretty exciting area that I just wanted to be sure and mention as part of my talk here. I'm going to be talking about individual tree species, but a point that Richard made forcefully that I'd really like to emphasize as well is that forest cover in general is important. If we can maintain and increase forest cover, that's one of the most powerful things that we can do in helping address issues raised with greenhouse gas emissions. I'm going to refer here to a report for the CRD by Stantec Consulting, where they were looking at community greenhouse gas emissions. In this case, they used emissions factors for land use change. These emissions factors are simply a way of converting some kind of human activity into greenhouse gas emissions. In this case, They were looking at the years, let me see here, 2007 to 2018. So if you had a hectare of land that was forest land in 2007 and in 2018, in other words, if the forest remained, then the factor that was used in calculating greenhouse gas emissions was that hectare of forest land sequestered 556 tons of carbon dioxide equivalent per hectare. And I show this just to emphasize that obviously that depends on the type of forest, where it's growing, age of the forest, and so forth. But just in a very comparative sense, forest lands had an emission factor of 556 tons of carbon dioxide equivalent per hectare over that measurement period. Grasslands, less than half that. Wetlands, still important contributors. Croplands, considerably less. And of course, settlement areas had an emission factor of 0. And so if you can maintain forest land as forest land, that's probably the single most important thing you can do in terms of carbon sequestration. Obviously, it has all kinds of consequences that have to be considered. We need to have some cropland if we want to be able to grow our own agricultural crops. If we maintain a large proportion of the land base in forested habitat, we need to be concerned about issues like wildfire. But all of the things being possible, if you can keep forested land as forested land, that's a big step. And there is going to be some logging going on, but keep in mind that those sorts of activities are going to have an effect on greenhouse gas emissions as the land is converted from one sort to another. The question of how the individual tree species are reacting to a changing climate. I received this timely email from someone I believe is with us this evening, just yesterday, about some cedar that were dying. Before I get into individual tree species, though, I want to come back to something that again was raised earlier by Richard. Climate change is affecting all of the species in the ecosystems. I think it's safe to say that in a forest on Salt Spring, we might have a pretty good idea of the tree species, the vascular plant species. Because Salt Spring has so many clever people, we might even be some ways along towards understanding a lot of the non-vascular species. Have a much poorer understanding of the fungal species and very little understanding of most of the other organisms that live in those woods. If you can understand, if you have a good list of the, let's say, the vascular plant species, the non-vascular plant species, the animals larger than insects, and some understanding of the insects, then you might have a good list of, say, 0.1% of the species that live in that stand. As for the other 99.9% of species, we probably don't know what they are in the stands, and so it becomes a little difficult to predict how they're going to react to these changing climates. But we'll focus on trees today, always keeping in mind that we don't even know the names of the vast majority of the species that are living in those ecosystems. I like to work with fungi. I did my master's in fungi. We have counted so far about 3,400 species of larger fungi in British Columbia. That's about twice the number of vascular plants we have, for example. And I think the correct number is probably closer to 10,000 than 3,400. So we have a lot to work on, but let's just focus on some trees today. So this is an email I received yesterday from a friend who went for a walk in a park in Machosen. And today she was counting cedars, of which 30 of 40 were dead. These are Western red cedars. This is a hard and sad question to ask. Are they all going to die? Well, eventually, yes, everything dies. Will they die in the next little while? I didn't know. So I went out to the 100-acre wood this morning. You may notice I'm wearing the same shirt I'm wearing tonight. To have a look at the trees out here. And there were an awful lot of dead Western red cedars, and a lot of them are fairly recently dead. They still have foliage hanging from them. The fact that Western red cedars were likely to die was predicted pretty early on by Richard Hebda and others based on climate modeling and the needs of the species. And really, when we started noticing trees dying, when I started noticing trees dying in this area around southeastern Vancouver Island, southern Gulf Islands, the first trees that I noticed dying were Western red cedars. And so it's good we have Richard here tonight, who's quoted here talking about the decline of Western red cedar in our new climates. But Western red cedar was sort of predicted and expected to decline, and there have been some other surprises along the way. For me, what happened to arbutus about 5 years ago and happened to arbutus about 6 months ago was a little bit unexpected. And I know an awful lot of people here will have seen arbutus with their leaves affected by fungal leaf blights. These are fungi that there's at least a dozen species that attack the leaves and essentially defoliated a lot of trees in this part of the world. They did so about 5 or 6 years ago. Some of the trees died, others didn't. They have defoliated a lot of these trees again, and very heartening fashion, a lot of the trees seem to be responding very positively and putting out very healthy looking new leaves. We shall see what's going on. What's interesting to me about this whole system is that the fungi that are associated with leaf blight on arbutus are, as far as we know, as far as has been identified, a variety of different native species. That is, these are parasites that have probably lived with arbutus trees for 10,000 years. And the sorts of effects that we're seeing of these parasites on the trees now suggest that something has changed in the relationship of these arbutus trees and the leaf blight fungi. Host parasite systems don't generally quickly kill the host. And yet that's happened it happened last time around with a lot of the arbutus, and it may happen again this time. At least they're being very hard hit. And my best explanation is that these arbutus trees are under an awful lot of stress because of changing climate, probably drought stress from previous year. And the effect that we're seeing on these trees is that a system between a host and parasite, which usually exists in some sort of balance that doesn't kill the host, is sufficiently out of whack that some of the arbutus are dying. And that's something that's caught a lot of people's attention because an awful lot of people love arbutus, including me. When the cedars were dying, I would sometimes try to console people by saying, well, we can understand the cedars dying. We can understand the mechanisms behind the arbutus decline, but at least we can always count on Douglas fir, which is adapted in some cases to warmer and drier climates than we've been seeing so far. So it's with considerable alarm, I think, that a lot of people are seeing Douglas fir decline happening on Pender Island, on Salt Spring Island, on southeastern Vancouver Island, we're seeing a lot of fairly recently dead Douglas fir trees. And the fact that we're also seeing, as Richard pointed out, shore pine dying on the Sunshine Coast, if we lose some of these tree species, which we consider to be more characteristic of the drier ecosystems, the next step is essentially non-forested ecosystems. And that's a huge change for a whole host of reasons. And then I was up in Haida Gwaii in 2019. I'm up there each year for a while doing work, and started seeing quite a bit of dead salal. And this is likely a combination of drought and cold winter temperatures. I haven't seen a really good explanation of it in the literature yet, but I was getting reports from all up and down coastal British Columbia of salal dying. And I don't know about people here, but for me, if we're starting to lose a keystone species like salal, if we can't keep salal alive in our rainforests, I think we're heading for big trouble. I'll also mention, although I don't have a photo of it here, we had a number of reports. There were at least 50 dead Sitka spruce trees near Souk over the last 2 years. And although you can find occasional Sitka spruce trees around the South Island here, their true climatic home is really beyond Souk and up the west coast. And so it's those trees that are just getting into the very drier part of the Sitka spruce range that were dying in some numbers last year and the year before. Another species to keep an eye on. Now, I mention a species to keep an eye on because all I've given you tonight are anecdotal reports. I don't know of programs that are designed to systematically evaluate the rate of death of any of these tree species so that it becomes possible to say objectively and numerically that the rate of death of these tree species has increased. So in terms of things that we ought to be doing, that we're not doing, I think one of the things that would be really helpful is to be able to get a better idea of the rate at which these trees are dying. It's not something, as far as I know, that anybody is monitoring systematically. Perhaps there's a role for trusts and local natural history communities and people like that. So then I started pondering, what are some of the actions that would be helpful in addressing these issues? And one of them, I think it's important, and I say this sincerely as a municipal politician, and I say it maybe a bit tentatively because I know as a young biologist, I was brought up to believe that the second worst thing that could happen to you was you would die. And the worst thing that could happen to you was you become a politician. But I think that the first thing I would encourage people to do is to demand better of your politicians at all levels, at federal levels, at provincial levels, at island trust levels, at municipalities for those who are visiting here from municipalities. In a lot of cases, scientists have been warning about and predicting fairly accurately the sorts of changes we're going to see in climates, ecosystems, and species, and laying out all kinds of helpful solutions at the feet of politicians at all levels. And the only thing that needs to happen is for the politicians to take some action. This has been especially frustrating to me in trying to deal with issues around old growth forests of late, where the provincial government commissioned an old growth committee that gave them an exceptional report, and now all they have to do All that remains is for it to be implemented. We have a federal government that probably knows, if they listen to anybody giving them sage advice, that they shouldn't be investing large amounts of our tax dollars in continuing to support and promote fossil fuel extraction industries. We have a provincial government, our current provincial government, that has hugely increased the amount of money it uses to support fossil fuel industries in British Columbia over the last provincial government. I think we ought to expect and demand better of the people who have it within their area of responsibility to change these things. And as Richard says, where we see this absolute abdication of responsibility, we start seeing people out blocking roads and so forth. One of these solutions that I think has an awful lot of promise and a solution that is strongly supported by groups like the Conservancy and other land trusts is natural climate solutions. That is trying to maintain our ecosystems and their sequestration possibilities. As Richard says, it's all well and good to have federal and provincial tree planting programs, but they can never, ever make up for simply trying to protect some of these ecosystems in the first place. And then the other two suggestions I'd like to put out there, but I'm happy to discuss any of these, are first of all, Richard's suggestion about fire smarting forests. I think it's a very controversial area. I think there are great opportunities if you don't follow we've had the fire smart rules for our municipality, and some of them would remove so much forest around any sort of a house or a community that there would be very little forest left. But in a less aggressive fashion, the forest can be thinned, the number of trees per hectare can be reduced to something closer to what we would expect in an old growth forest, at the same time reducing the risk of fire spread. The wood that could be left on the ground could be the large wood, which is not the sort that spreads these fires, and some of the smaller material could be removed and mulched and returned and so forth, as Richard suggests. So I think there's all kinds of community opportunities there. And finally, let's try and find some systematic way as communities to monitor what's happening as ecosystems change, because there's nobody else doing that. So I think the communities have a great opportunity, if so motivated, to step up and fill some of those gaps. I think that's about the time I was allocated, so I'll shut down here, and I'm happy to answer questions or join in discussion.
Thank you so much, Richard. And just to start off with, I'd say that on the political side, you both stimulated a lot of discussion here. There's been extensive discussion in the chat about both NAPTEP and the development permit areas. It's been very productive. I'm going to refer most of our viewers to that, and it will be passed out in the chat. And it's really a good discussion, and there's so many things to be done and said. As Laura Patrick, who is our island's local trustee, has said, she says here in the chat, please demand better of us and help us build greater understanding. And I know for us, it's both the issue of there are a couple of tools. We need more tools, as Richard said, to get control over this situation. Someone was asked, I believe Karen Olson asked, why are trees being trucked off the island? We've had some big clear cutting operations on private land. They're a serious problem. We're facing this. It's really wonderful to keep the discussion going. So thank you for that.
Sorry, if I might follow up and thank Laura for that, and also thank Laura for being a trustee. I hope people listening appreciate that being a representative of local government is oftentimes not an easy job. It's oftentimes a very thankless task. Speaking firsthand here, and so I hope everybody takes the time to offer their thanks to Laura for her insights on this.
Yeah, and Gary Holman has chipped in here, and the discussion with several members of the community was very good in terms of let's look at these tools and work on it. So this is a transition salt spring conservancy event in the future. I'm sure trying to move ahead on this. Going back, I might ask a couple of the questions. This one probably more for Richard. In the future scenarios, why doesn't the coastal Douglas fir on Salt Spring expand? And what would be the reason for that in terms of the climate change, the effects of climate change, Richard, in terms of the models?
So Andy has observed, and I have also observed on my own property, the problem that on dry sites, no trees will be able to grow. I've seen arbutus die in dry sites, and you have to think of it this way. There's only a finite amount of soil space and water that it can hold. And at some point, especially on rockier or shallower soils, that volume does not hold enough water for Douglas fir or any tree whatsoever, and the trees will die. At the higher elevations, where you have a little bit and not very much coastal western hemlock on Salt Spring, that dry coastal western hemlock ecosystem will probably, at least for a while, be replaced by forests in which Douglas fir occurs. The problem is, and Andy emphasizes, is we have no way of knowing what the path to future ecosystems is. We don't know, is it going to be a pest, an insect pest, or a fungus, or an extreme drought event in which there will be insufficient water for any trees, because there's a limit. In terms of water, there's a certain amount of water the trees require, even in the as well drought adapted as they are. So the bottom line is, at least from the fossil record and from the models, and from what most important from what we're seeing today, is summer drought. No matter how much rain there's going to be in the winter and how concentrated it is, which it is, summer drought is going to be so intense and so long-lived that woody species, at least tall woody species, just because of their physiology, will not be able to take water from the ground. There won't be enough, and be the growing points at the tips of the branches, and the tree will die. And some trees, they're able to resprout, and Western red cedar is good. They get what's called epicormic growth. They'll kill off the tips and the end branches and then start growing from the core, which they protect at all costs so they can go. Other trees, and Western hemlock is the best one I know of, if they get too dry, they just die and they drop all their needles. They don't give you a warning like a cedar does. Just 1 year there, it's there. The next year, you just see a stick with branches because it could no longer supply. So it's just the changes in conditions are such that in many cases, trees just won't be able to grow, or maybe very limited species like oak. And the other thing is we really are into a time of, we don't know what the pathway is going to be to the future and what's going to get what where. And all it takes is, as Andy pointed out, is a change in the shift of balance between a sort of low level pest and the tree, and then out it goes and it takes over. The best example is the mountain pine beetle. The other reason the mountain pine beetle probably was so successful is the trees were weakened by summer drought. So A, they don't get killed off, and B, they are weak when the summer comes around, and the tree and the beetles kill them. Not only that, there were so many beetles, the population level rose so high that there was no tree that would escape them unless it was very, very tiny. And then they would attack ponderosa pine, which they killed those off, and they'd go off after other species as well. So that you can get an extreme event like that, and it doesn't matter what you do. I think the main issue here is there's just no gradualism anymore. There's just, we are at the mercies of biological and climatic systems we have unleashed. and uncertainty, and we have to hang on. But the one thing I absolutely know for sure, and Andy said this, and I'll say it again, is you must keep what you have. It's at least alive and doing something, and it's figured it out for the time being and may have some capacity to take a few hits. If you put it at risk through the development or degradation or removing it, all bets are off and the landscape is now unstable and so out of equilibrium that it'll go somewhere we don't know where.
I'll also just to add a little bit to Richard's there, especially on a place like Salt Spring, the topography, slope, and especially soil depth are going to be critical. So if you look at the decline in arbutus from the leaf blight, it's certainly most pronounced on the arbutus that are shallow rooted over bedrock. You get an arbutus on a nice site with deep rooting. It's probably got access to a little bit more water. Will do a bit better in these extended summertime droughts. Same with Gary Oak. At Gary Oak, all up the slopes of Mount Maxwell above Burgoyne Bay, there growing in, 10 centimeters of soil over bedrock. And those are the sorts of trees that are going to be most vulnerable to increased summertime drought.
You have a tremendous opportunity if you get the good information that you want. You want really good superficial cover maps, good soils maps. You've got tremendous detail in terms of aspect, slope angle. You have fabulous capacity to be able to map in great detail the terrestrial ecosystem, plant communities on your entire island. And you've got powerful tools, the CRD. I think Salt Spring is under the CRD Atlas, is it not? Covered by the Atlas? Or is it not? I can't remember. But anyway, if you're in the CRD Atlas, you have a fabulous tool and map the natural, physical, and biological landscape in detail. And then it's easy enough to identify those plant communities that are going to be most at risk. And you start with those, but don't be gradualistic about it, because I'm willing to bet the most at risk ones, they're going to change. There's absolutely nothing you can do about those. But as you move up the scale to ones you think might be less at risk, they're all at risk. And I think, as Andy has pointed out, all the species are at risk because of changes in their status, whatever it is. They may have more capacity to deal with drought, for example, but any change in the status of the nutrition or the moisture levels or pest relationships put a species at risk.
There was a question, Andy, that you could maybe answer. What do you do with the leaves of these arbutus? Do you just leave them and let them fall to the ground, or should you be doing something? Certainly, the Fire Smart says one thing.
Yeah, it's good practice to remove the leaves and move them away from the trees to some composting place or something if that's possible, because some of the species of fungi will continue to produce spores on the leaves even after the leaves are dropped. So you want to remove that potential. That doesn't happen in all of the species which are parasites of arbutus leaves, but it does in some of them. So the best practice is simply to remove the leaves and compost them somewhere else if that's a possibility. Get them away from the trees.
One person asked, and I've lost track of where that chat item is, but one person asked, should we water the trees? Is there an argument for watering trees on our personal property?
I would. Because if it's a tree that's important to you and you have the opportunity, and summertime drought is what's causing the problem for that tree, then a good deep watering in the midst of a summertime drought, one good deep watering might make the difference for that tree. It's not something we can do for most arbutus trees, but if it happens to be a tree that's near and dear to your heart, as many arbutus trees are, then I don't see a problem with it. Richard?
You sound like also considering our summer water shortage, sounds like a good argument for getting water storage as well. And then you could rationalize it probably even more.
I think Andy's right for trees that are special to you. I think one of the things that was interesting when we observed with red cedar was that single trees out in the middle of lawns actually did very poorly in dry years in the 1990s. And that is because lawn thatch takes up all the water. It's really very strong and capable of any water in the summer rain that, for example, falls, just doesn't get to deep water. So what you want, the rain won't get into the soil. So what you really want to do is keep the winter moisture in the ground. So one of the things you do not want to do is compact the ground around your trees. And here we get into trees do not grow as individuals. I just had to laugh. Old Bruce Springsteen, yeah, maybe it was him. Anyway, rock guy on the radio says, we got to save those trees, right? Every old tree's got to have at least an acre of forest around it. And I go, this is a classic example, and this is how it's practiced in British Columbia. Big old trees, just leave an acre around them or a hectare and they'll be fine. Utter, total hogwash and nonsense. We don't live in acre or hectare large ecosystems. We live in a continuum of connected organisms. So one of the things that I would be doing if somebody has trees, they're special to them, and they've got lawn, or they keep the growth down underneath this, bring in a shrub community, maybe relatively low, where the organic material from the tree itself, from conifers, and from the shrubs accumulates and creates a porous, sponge-like soil under the tree. Then there will be deep penetration and long-term storage of the moisture. I give a great lecture on the importance of organic matter in soils and the value of mulch. So probably if you're going to do that, then mulch with natural material and then bring living material in. And then there's a great technique, Andy may know more about it, called myco-mulching. And that's where if you've got heavily compacted soils, they've used this on forestry soils, you bring in organic material, you inoculate fungi into it, and they very clearly, very quickly, the mycelia will bind the organic material, begin to decompose it, and they'll even bind onto the underlying material and whatever it is, if it's compacted, and create a much better water storage system. So rather than water, I would mulch and make sure that the water from the wet season stays there a long time, and there's a lot of porosity and loose texture in it. And then, yes, if they're special to you, go for the watering.
Yeah, both of your answers were echoed by several people who are outstanding gardeners from the island. That came through the chat as well while you were talking. So terrific, in agreement with that. How's our time? We have gone over our 9 o'clock, and maybe a couple more questions. Is that okay with you? And then we'll call it off. Is that sound good?
Sure.
Okay. Someone asked about wetlands and forest-based wetlands. Certainly, you mentioned marine, essentially blue carbon wetlands. What about forest wetlands? Can you comment on that?
Sure. Forested wetlands, there's a whole bunch of different, well, first of all, wetlands are in short supply in the Southern Gulf Islands compared to most of British Columbia. They're precious. They harbor species we don't see anywhere else and ought to be protected. Any place development takes place, they tend to be particularly destroyed. And some sorts of wetlands can hold remarkable amounts of carbon in them. And particularly bog wetlands that can store an awful lot of carbon, but all wetlands store considerable amounts of carbon, surprising amounts given that they don't have things as big as trees in them.
And I would add to this, first of all, wetlands are absolutely vital in water management on landscapes. They create potential for water detention, especially because we're going to get these and have already examples of heavy rainfall events. They essentially slow down the loss of movement of water, as will a good thick forest soil, by the way, down the slope, usually toward the shoreline or lower reaches of water courses, where then you end up with flooding, which is going to be an intense problem. It's particularly in small watersheds with steep slopes, and Salt Spring has those. They were going to be such intense rainfall events that there will be flooding, especially at the level of the ocean, because the ocean level is rising, and at a high tide, you get a king tide, you're going to get flooding. So there's one issue there. The other thing that I see is happening a lot on the islands, or has happened, is people say, well, we want topsoil. So they, on private land, they immediately dig the hell out of a basin filled with organic matter, and they call it topsoil, which the hell it isn't. It's beautiful dead organic matter, but it's highly acidic and nutrient poor usually. And then they mix it with stuff and sell it to you as topsoil. That is utterly wrong to do. So aside from their biodiversity value, they have tremendous water management values. And the other thing is we have the same problem. Like, A, nobody should be filling on them whatsoever. And B, they need a zone of life around them as well. Okay, well, we can build right to whatever, 5 meters from the edge there up or whatever. No, again, they're part of a continuum. This kind of leads me to a point I harp on all the time. How much nature do we need to save in the context of climate change? All of it. There's no 12%, there's no 25%, all of it, not just the forests, but all of it. The living skin of the earth needs its help, and we need to stop hacking away at it. You know, at what point, when you strip off your skin or get burned, are you incapable of surviving because you are no longer able to maintain the loss of water and other characteristics of the superorganism? And that includes the cities. And Andy showed a great picture there of an urban area. Even in urban areas, we need to restore the tree canopy. And frankly, with all due respect, forget the view, man. Forget the view. Yes, it's great to have them, but the view does not override A, the rights of the organisms, the inherent rights of the organism, and B, our vital need for them to be there. So with all due respect, if there's somebody out there from the prairies who thinks that they don't like it because they get scared by trees, what are you doing here? And I've heard of people, the first thing to do is they cut all the trees down because they're afraid of the trees around. This is not the prairies.
If I might just add a wee bit to Richard's there about wetlands and wetland protection, I think any regulations or zoning or land use around wetlands has to very carefully consider the processes involved with wetlands, more so even than a lot of other development areas. We differentiate different types of wetlands based on the sorts of drainage that's present in the wetlands, what drains into it, what drains out of it, what drains through it. And above and beyond the sort of wetland, you also have to think about what that means in the broader landscape. Most of tonight's talk is focused on extended summertime droughts. But as Richard also pointed out, we're going to have some models, the total annual precipitation may not change all that much. We just won't get very much in the summertime, and we'll get way more in the wintertime in way more intense events. And all these issues around drainage are going to become much more critical than they are today. So when you're thinking about wetlands and development and all these sorts of questions, think about processes, think about drainage, think about what that wetland is doing for everybody who's living around it, for heaven's sakes.
Yeah, and even the dry valleys, swales and various other forms of retaining water are going to be more and more necessary, I would think, in keeping the forest wet. And as Mitchell Sheeran pointed out in the chat, the wet forest actually protects our houses as well as the rest of our nature. So we need to keep that up. Here's a question from a person, Red Oaks. Could you suggest maybe 5 tree species to plant in looking forward? Obviously, Gary oak is one, but are there other ones that kind of are appropriate, even if they might not be native species?
Well, first of all, there's somebody has been trying to get us to grow Paulonia, the empress tree. And, because it stores carbon. Well, yeah, it stores carbon. It depends on what you grow. It becomes incredibly invasive. Then that's true for a whole bunch of other species you might try. So this is not the answer. This is kind of like, let's reduce it to its utter simplicity and not worry about any of the issues. So first of all, that's one issue. But there are some interesting species, and in the extended version of my talk, I talk about Oregon ash, which is a native species. There's not a lot of them around, but we again know from the fossil record that it used to be at one time much more abundant, significantly abundant, so that you could notice that it was there around Saanich Inlet. That would include the Salt Spring Island. So there may be some circumstances in the context of climates and sufficient moisture that is a species that has some merit. People have in Victoria, they used to plant redwoods, right? And for a while, it was a kind of a signature tree, show off. I'm a rich modern guy. Here's my 2 redwoods. There's a park in James Bay where they're planted. Well, so there's an area where it millions of years ago used to grow here. Problem is, they're moisture sensitive too, and so that's not a tree I would choose, because if you look at the ones in town, they're dying from drought, because where they come from, at least the coastal ones, they have fog. Well, we don't have fog. The temperatures may be okay, but the moisture conditions are no longer appropriate for them. So I think we have to be very careful when we look at introducing new species, but we shouldn't be afraid of them. But it has to be a very thoughtful thing. And the way I suggest people attempt to do this, to think about this, is carefully choose the ones that you want and begin preparing your landscape. You can do this on Salt Spring Island by implanting the species you're interested in. And if they're the right ones, then they, as the climate changes and the surrounding trees are less competitive, whatever, may indeed spread, and you maintain your forest cover continuity. And that's another very important thing that's necessary for moisture management, because if you remove the trees, you intensify the water shedding off the slope. So one of the things, when Andrew was talking about wetlands, it reminded me, all planning has to be done on the watershed basis. You cannot plan on the lines that humans put on the landscape. Back to mapping. Map the watersheds, map aspects and slopes, map the texture of the soil. But yes, there are thoughtfully considered additional species that can be brought, and the way to do them is to implant them. Put them, and this is what we do with our cherry oaks on our property. We've implanted them in anticipation of the bitter cherries dying, which they are, we know they are. And so they'll be established, and gradually the root system will be there, and they'll be able to expand. Some may not. Maybe the changes won't be there, then the tree may just fade away, so to speak. But it's now is the time to begin this process of transforming a landscape, building up the insurance capacity of your forest ecosystems. And implanting, for me, I think is a really valuable mechanism in suitable sites. Like I was talking about Gary Oaks in plectritis sites. That's a very thoughtful, likely very successful strategy.
Andy, did you have any comments also on that?
Oh, I think Richard explained it very well. The Oregon ash is an interesting idea. I think in the end, it's nice to have a number of tree species to select from, but the decisions are always going to be made on a very site-specific level. So it's kind of impossible to say, without knowing the property, without knowing the land, what the best tree for the site is.
and you can start with native species as well. And we're planting a lot of smaller, red osier dogwood and holodiscus and so forth. Just trying to start some reclamation in what was otherwise a blackberry field in our property. So it's kind of fun to do as well. I know I really liked your idea of doing some citizen science around what trees are dying and where they're dying. Also, citizen science around looking at how we can keep our valleys wet. And there's certainly going to be there's a lot of overlap between properties in those valleys that where people could work together to try and maintain that over time. So it's not just the planting of trees, but it's also looking at the landscape and trying to maintain the forest values that you mentioned. I think we're near the end here. There's lots of people are saying red currant, Oregon grape, snowberries, some of the shrubs that I mentioned. I think we've really could go on, but I think it's appropriate time. I know Andy has a very good brew waiting for him at the culmination of this, and I don't want to keep him from that too much longer. In fact, I might find one in my own fridge. Thank everyone for joining us tonight. Please read the chat. It will be sent out by Erin Ann, and I'll leave it. Are there any other announcements from Patty or Susan or Erin Ann? I'll leave that now.
Well, yes, of course, wish to thank everyone for coming, and certainly to our presenters, Andy and Richard. Would like to let you know that we're going to do our very best to get all the questions that were not answered for you when we send out the recording of this, as well as we hope to solicit some of the support from Andy and Richard in terms of answering those questions for you all. So thank you so much to everyone, and I wish you